Hello, everybody. It is piecewise time. So piecewise just means pieces of a graph that hang out together. There's basically, when you look at them, you're going to say, oh, look, there's a squiggle diggle right there. And then you can see that there are more than one function at a time here. And then you're just going to break them off for where they're asking. Okay, so like starting with this first one, it says the function x plus 1. You know that you would start that with a y-intercept of 0, 1, and then go up 1 over 1. I mean, this is good old stuff here. That's going to happen until you get to 3. So you're going to start here. There's your first dot. Then there's another one. And then at 2, and now at 3, the graph is going to stop. Now, one point I want to point out, point, see how I've filled that in. That is because right there, it is a less than or equal to. So this is going to shoot off this way. And then here, you don't have to do them in a different color. I'm just going to so that we can see them and figure out what it is. At 4, or excuse me, at 3, it's just going to be that solid line of 4. All of this horizontal line. Now, technically, this segment right here looked like an open circle, and then, but because that open circle overlapped right where the other solid circle was, it's a filled in point. So f of 3 is 4. I'm going to have you try number 2. This is something where we'll go back and discuss them. The other option is that you can graph them, but I want you to be able to see how to do them by hand. So you're doing number 2. Now let's scroll down. All right, I'm up for number 3. Now, up the ante just a little bit. Let me move my face. In this one, now I have a quadratic. I have x squared. And it says x squared for x is less than or equal to 2. So you're going to just go out like normal and start plotting that parent graph of x squared. 0 squared is 0, 1 squared is 1, 2 squared is 4. And that's as far as I'm going to go on that side. And I'm going to make sure that I fill it in because of that less than or equal to. So this is going to go all the way up. Now, for the second one here, it's saying for x is greater than 2, it's going to be this function right there. If that makes you stressed out, write it in the order that you like, okay? So y equals negative x plus 6. So first, we know it would have a point at 1, 2, 3, 4, 5. There would be on the graph, there'd be a point right there, right? And then there would be one here, and then there would be one here, and there would be one here, and that's how we would graph it. The important part to remember is that this section of the graph right here, you know what, let's try a highlighter. This section, apparently that's a no. Make my own highlighter. This section here, the whole function, if I was graphing on the domain of all real numbers, that would exist and go up forever. But because it said only graph that for bigger than 2, that's where we're going to be right there. And again, this is a situation where the one side, that's a bad color for that. The one side is filled in, the other side is like a little hula hoop that it counts that it's still there. It's still going to be filled in. So at 2, my answer is 4 again. This is the moment I pause and tell you, no, not all answers are 4. Okay, next on my list, you're going to try 4. Look, it even says it. Here you go. Bloop, bloop. Your turn. Yes, there's 3 now, but I want you to take a look. Oh, dear, I just erased it. This is vertex form, and you may remember, you may not. I'm going to write it out first. I mean, you always have the option of plugging in any number that you need. And it'll give you out the y value. This one right here, vertex form, HK is that vertex, okay? And then you would have, so because this is our horizontal shift, the 1, and the 4 is the vertical shift. And then it's going to have the same stretch as the one that you just worked on. Again, if what I'm saying is confusing you, if what is she talking about stretch and what does it look like, go ahead, plug the points in, and you'll get out the y values, okay? This section right here is going to be a horizontal line. Keep that in mind, okay? So now we have more fun to do together. Are we doing 5 together? Oh, we are. Yay. Okay, so piecewise, and we're talking about absolute value. So absolute value looks like that. What's absolute value doing? Absolute value is talking about its distance away from 0, correct? So all of these values that are negative here are actually positive. If I were to pull that sample out, how else could I describe this graph? Well, it's a graph with a negative slope, right? So you're going to say that it's just x if x is greater than 0, but call it negative x if x is less than 0. Now, what you should be thinking about is that, yes, there is a filled in spot right there, right? We know that that is a continuous function. So one of these needs to include the equals to. It doesn't matter which one in this case when you're writing the equation. All right, I'm doing 6. Let's go. 6. Okay, now it's going to get, wow. Now it's going to get fun. So first, here's the picture. Woo-wee! Now I have to write the equation. So I'm going to come over here and I'm going to call it f of x. I'm going to make my squiggle. I'm going to go ahead and underline this part blue, and then I'll underline that as something else. So now I want to talk about, there's 2 things that happen. 1, we're going to figure out what the function is, and then 2, we're going to figure out where the function existed. So the blue squiggle that we're representing here starts here. We can see that this is at 3, and it's all the values that are less than 3. So I'm going to say x is less than 3, okay? This open circle right there is why I'm putting just less than, not less than or equal to. All right, now the fun part. Ways you can do it. You can go ahead and you can do the slope and then plug in a point. You can write 2 equations and solve. All of it makes me happy for you. Let's do a rate of change just for, funsies. So rate of change, I'm going to say 6 minus 5, and then -1 minus 2. So that's going to give me 1, and -3. So when I write my equation, I'm going to say that I have, where to put this? Okay. Y minus 6 equals -1/3 x plus 1. And then you can just go ahead and add the 6 over. And so you'll have -1/3 x plus 1 plus 6. Okay, so that's just using this form right here. Put our m here, and then you may see it with like an x1 and a y1, and that's just creating the equation of the line. Again, if that's stressing you out, it's just quicker. But if you don't like it, it's not a problem. Just use y equals mx plus b, x plus x plus b, and solve it that way. You just have to now multiply by a fraction. That's all. Now over here, new color. Boop, ba -da -boop, ba -da -boop, ba -da -boop. All right, so this section we're going to talk about now is starting at 3, but now it's going to be the values that are bigger than 3. But notice the difference here. This is filled in. Fill in means that we are going with the symbol and that, except that's the wrong symbol. Filled in this or that, depending on where you're going. So that's set for that right there. All right, now let's rock this. You're going to go through. You're going to find the slope of this one, or you can set up two equations, or you can run a regression. I don't care. And you'll get the equation of that line right there. Okay? So you've done that one. You're going to try 7. 7's a beaut. More segments. I love it. All right. And then I believe I'm doing, look at me, I'm doing 8. Okay. Here we go. Now, same but different. So g of x, why did I pick g? Just because I wanted to. This is going to have 3 segments. So I'm going to make this one the orange one so we can keep track. I'm going to make this the yellow one. And then I'm going to make this the green one. All right, here we go. This one, going forever until that -2. So the orange statement, I'm going to say that's going to happen when x is less than or equal to 2. All right? Then, looking at its equation. Now, here's another way. You can pick 2 points and do the process we did. Or you can identify pretty quickly the slopes 1, 2, 3, 4, 5. So -5. So that's a line with -x. What did I say? 1, 2, 3, 4. No, sorry. -5. So there's the orange one. Ta-da! Moving on to yellow. Now yellow, I can see that is making the right ratios I want for the parent graph. That it's 1, 1, and then 2, 4. So that, just based on those ratios, I can identify, and it also has a vertex right there at 0, 0. That is just good old x squared. How you doing, buddy? And then where does that happen? Where does that take place? Well, the last one stopped at -2. So this one starts at -2. So you're going to say -2 is less than x, which is less than 2. Notice they're both open circles, so that's why the less thans are showing up. And green section, best for last. Horizontal line. Where's it going? Oh, it's at -1. Boom, bada bing, boom. And where's that one picking up? Solid line at 2. So you're going to say x is greater than or equal to 2. Fabulous. Fabulous. What number are we on? 8. Oh, golly gee. All right, here we go. Got exciting. I'm going to do the same thing and color section them off because that works for my brain. Hopefully it works for yours too. And we probably can't see it because my head's in the way. Okay, so I don't know. H of x. Let's do it. H of x. Make a big squiggle. And we'll go left, right. So this section, horizontal line, they're my favorite. Right there at -5. -5. Bam, boom, boom. Where does that happen? Everywhere, all the way negative, 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 until I get to -1. So you're going to go spoop, 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 -1. X is less than -1. Now I'm going to hold off on the next symbol, and you'll see why. Let's go to our friend the yellow. Hello, yellow. Now, a couple things here. Yellow is upside down from where it should be. It also has a vertex of 1, 3, not 0, 0. But as I look at it, it still has the ratio over 1 that the first level got squared, just moved up 1. And then, oh, you know what? They may be tricking. We have work to do. Okay, That's a bummer. So we're going to write y equals the stretch, and then I'm going to do x minus 1 squared plus 3. Then I'm going to pick a point. 0, 1 looks good, right? So I'll go right here. 1 equals a times 0 minus 1 squared. So I have a, because 1 - 1 squared is 1 plus 3. And oh, good thing I wasn't just slinking around there. Subtract that. A is -2. So I have to go -2x minus 1 quantity squared plus 3. And this happens from -1 up to 2. You can see where the yellow section is. Now, definitely a 2 open circle, so that stays like that. Here, we have no idea what technically happened, but it's filled in. So call one of them open and one of them closed. Now it's filled in. All right, last section. I can see I have linear here, and I can see the slope is, switch to green, I can see that the slope is 2 over 1 up 2, okay? So technically 1/2 backwards, sorry. Nope, up 2 over 1, sorry, I'm tired. So up 2 over 1, so I'm going to go down, all right, so that means slope of 2, 2x minus 5. Where does this one occur from? 2 filled in, out to 4. And I just made a boo-boo because that is open on the end there. I know. These are cool. All right, so you're going to do 10 as well. And you're going to be awesome. And I'm going to see you in class. All right, you have a super, super day.